Hello, Acute Angels. This is Teacher Anna, and welcome to another Matinic episode. In this episode, we are going to talk about geometric means, geometric series, and the other types of sequence. Well, at the end of this lesson, you are expected to determine geometric means and some of the terms of a given finite or infinite geometric sequence. Illustrates other types of sequence. So, what do we mean by geometric means? Well, when we say geometric means, these are the terms between any two non-successive terms in a geometric sequence. For instance, if we have the geometric sequence 4, 8, 16, 32, and 64, the term between 4 and 64, which are 8, 16, and 32, are called geometric means. Now, if we have A, M, B as sample of geometric sequence, M is the geometric mean between A and B, we can identify the value of geometric mean if we equate the two ways in determining the common ratio. Remember, for us to get the common ratio, we divide two consecutive terms such as a sub 2 divided to a sub 1 or a sub 3 divided to a sub 2. Doing that will give us the same result. In our example, a sub 2 is m, divided it to a sub 1, which is a. The result would be equal to the value of a sub 3, which is b, divided by a sub 2, which is m. Then by a cross multiplication, we will be having m squared is equal to a multiplied to b. Therefore, aside from identifying the value of r for us to get the geometric mean, we can just simply use this formula. Again, it is only possible if we are only looking for one term. In short, geometric mean. Let us have some examples. Example number 1. Find the geometric mean between 2 and 50. Since we are only looking for one term, we can use the formula m squared equals a multiplied to b. For us to be reminded what is a, what is m, and what is b, we can illustrate the given and unknown. 2 is a, m is the unknown, and b is 50. Now knowing which is which, we can proceed to our next step, and that is the substitution of the given. We now have m squared equals 2, the value of a, multiplied to 50, which is the value of b. Then 2 multiplied to 50 is equal to 100. And since we are only looking for the value of m, we need to eliminate the exponent in it. Doing that, we need to square both sides. Square root of m squared is equal to square root of 100. The square root of m squared is equal to m, and square root of 100 is equal to positive and negative 10. Therefore, the geometric mean between 2 and 50 is positive and negative 10. We now move on to our second example. In here, we need to insert 3 geometric means between 5 and 3,125. As mentioned, we will be identifying 3 terms, so the formula that we use in the first example is not applicable here. But before solving, let us illustrate the given first. 5 will serve as the first term, then 3,125 is the fifth term, and we are tasked to find the value of a sub 2, a sub 3, and a sub 4. For us to determine those unknown terms, we need to calculate for the value of r, or the common ratio. How do we do that? Remember that in our previous lesson, we can solve for the value of r even if we only have 2 non-consecutive terms, and that is by substituting them in the general formula of geometric sequence, which is a sub n is equal to a sub 1 multiplied to r raised to n minus 1. Let us solve for the value of r. Substituting the given in the formula, we now have a sub 5, which is the value of a sub n, equals 5, which is the first term, multiplied to r raised to 5 minus 1. A sub 5 is equal to 3,125. Then 5 minus 1 is 4. And for us to get the value of r, we should eliminate 5. Doing that, we will be dividing 5 on both sides. 3,125 divided by 5 is equal to 5r raised to 4 divided by 5. 3,125 divided by 5 is 625, and 5r raised to 4 divided by 5 is equal to r raised to 4. And to eliminate the exponent 4, we will be getting the fourth root of both sides. Fourth root of 625 is equal to fourth root of r raised to 4. Fourth root of 625 is equal to positive and negative 5. Then fourth root of r raised to 4 is equal to r. Therefore, we have two values of r, which are positive and negative 5. This only means we also have two sets of geometric means. If r is positive 5, then to get the next term, we simply multiplied r to each preceding term to get the next term. In here, we have 5 as first term. Multiplying it to 5 will give us 25. Then 25 multiplied to 5 will give us 125. Lastly, 125 multiplied to 5 is equal to 625. Therefore, the three geometric means between 5 and 3,125, if r is positive 5, are 25, 125, and 625. What if r is equal to negative 5? Well, again, we simply multiplied negative 5 to each preceding terms to get the next. 5 multiplied to negative 5 is negative 25. Negative 25 multiplied to negative 5 is equal to positive 125. Then positive 125 multiplied to negative 5 is equal to negative 625. Therefore, the three geometric means between 5 and 3,125, if r is negative 5, are negative 25, positive 125, and negative 625. And that's how we solve the geometric means. If we are only looking for one, we can use the formula m squared equals a multiplied to b. But if we are asked to find two or more geometric means, we need to solve for the value of r first to get the unknown terms. Let us now talk about geometric series. What do we mean by geometric series? Well, a geometric series is the sum of the terms in a geometric sequence. For example, if we have the geometric sequence 4, 8, 16, 32, and 64, we just simply add them. Adding them basically means getting the geometric series. In this example, we have 124 as their sum. But what if we have many terms to add? Well, certain formula can be worked out. In geometric series, we will be applying different formula depending on their value of r. Let us have the first one. If r is equal to 1, then our formula would be s sub n is equal to n multiplied to a sub 1. For example, what is the sum of the first 5 terms of the sequence 2, 2, 2, 2, 2, 2, and so on and so forth? Well, before using the formula, let me show first how the common ratio is solved. R is equal to a sub 2 over a sub 1. A sub 2 is 2, then a sub 1 is 2. We have 2 over 2, which is 1. As we confirm that r is 1, We are now free to use the formula S sub n equals to n times a sub 1. Substituting the given on the formula, we now have S sub 5 as we are looking for the sum of the first 5 terms equals 5, the value of n, times 2, which is the value of a sub 1. 5 times 2 is equal to 10. Therefore, the sum of the first 5 terms of the sequence 2, 2, 2, 2, 2, 2, and so on and so forth is 10. Next, if r is negative 1, then n is even. The sum of the geometric sequence then is equal to 0. For example, what is the sum of the first 4 terms of the sequence 2, negative 2, 2, negative 2, 2, negative 2, and so on and so forth? Well, let's check first the value of r and n. For r, we have a sub 2 over a sub 1, which is equal to negative 2 over 2, which is equal to negative 1. And n is equal to 4, since we will be getting the sum of the first 4 terms, and 4 is an even number. Therefore, even without solving for their sum, we can already tell that the sum of the first 4 terms in the sequence 2, negative 2, 2, negative 2, and so on and so forth is 0. Next, if the value of r is negative 1, but this time if n is odd, then our formula would be S sub n is equal to a sub 1. For example, what is the sum of the first 5 terms of the sequence 2, negative 2, 2, negative 2, and so on and so forth? Let us check first the value of r and n. Getting the common ratio, we can use the formula a sub 2 over a sub 1. Substituting their values, we have negative 2 over 2, which is equal to negative 1. Then for n, we have 5 as we are looking for the sum of the first 5 terms, and 5 is an example of an odd numbers. And since we confirm that r is negative 1 and n is odd, we can already tell that the sum of the first 5 terms in the sequence 2, negative 2, 2, negative 2, and so on and so forth is positive 2, as we just simply substitute a sub 1 in the formula. For the fourth formula, if r is not equal to 1, then our formula would be S sub n is equal to a sub 1 minus a sub n multiplied to r all over 1 minus r. For instance, what is the sum of the first 6 terms of the sequence 2, 4, 8, 16, 32, 64, and so on and so forth? Well, for us to determine it, we need to solve for the value of r first. We can use the formula a sub 2 over a sub 1, and then we have 4 over 2. 4 over 2 is equal to 2. Then we will be substituting the given to the formula. S sub 6 is equal to 2, the value of a sub 1, minus 64, the value of a sub n, which is a sub 6. Now, in case a sub n is unknown, we need to solve for it before we can proceed in identifying the sum of first few terms in a sequence. To do that, we can use the geometric sequence general formula. But in here, it is given, which is 64. Then we multiplied a sub n to r, which is 2 in this given example, all over 1 minus 2. 64 times 2 is equal to 128. Then 1 minus 2 is negative 1. We now have 2 minus 128, which is equal to negative 126. Negative 126 over negative 1 is equal to positive 126. Therefore, the sum of the first 6 terms of the sequence 2, 4, 8, 16, 32, 64, and so on and so forth is 126. Well, the first four formula you have seen are all for finite geometric sequence. If you recall, in arithmetic series, we can only solve for the sum of finite arithmetic sequence because the numbers are getting higher and higher. So it becomes impossible for us to solve for infinite arithmetic sequence. In geometric sequence, it is also impossible for us to solve for the infinite sequence if the numbers are getting higher and higher because of the value of r. But there is an exemption to that, and that would be our last formula in the geometric series. If r is greater than -1 but less than +1, then the sum to infinity is equal to a sub 1 over 1 minus r. This is possible because as we get the sum of its first few terms consecutively, they are getting closer to one certain number. So, it becomes possible to get the sum to infinity in geometric sequence. Again, we can only use it if r is greater than -1 but less than +1. Let us have an example. What is the sum to infinity of 1/2, 1/4, 1/8, and 1/16, and so on and so forth? Well, let's check first if the value of r is in between -1 and +1. We can use the formula a sub 2 over a sub 1 in identifying the value of r. A sub 2 is 1/4 and a sub 1 is 1/2. Dividing the 2 will give us 2 over 4. Simplified it to 1/2. R is 1/2, which is 0.5 if we express it into decimal. And 0.5 is in between -1 and +1. Therefore, we can proceed in identifying the sum to infinity of the given sequence. Again, our formula for the sum to infinity is S equals a sub 1 over 1 minus r. Substituting the given to formula, we now have 1/2 over 1 minus 1/2. 1 minus 1/2 is equal to 1/2. We now have 1/2 over 1/2, which is basically equal to 1. Therefore, the sum to infinity of the sequence 1/2, 1/4, 1/8, 1/16, and so on and so forth is 1. And that's how we solve for the sum of geometric sequence. We use some formulae to make our solving a lot easier and faster. Now, let us talk about the other types of sequence. Aside from arithmetic and geometric sequence, we also have the harmonic and Fibonacci sequence. We begin with the harmonic sequence. What is harmonic sequence? Well, a sequence of numbers is said to be harmonic if their reciprocal form an arithmetic sequence. For example, 1/3, 1/6, 1/9, and 1/12. This sequence will be considered harmonic if their reciprocal form an arithmetic sequence. Meaning, in the reciprocal, for us to get the next term, we just add the same number, which is called the common difference. So taking the reciprocal of the given sequence, we will be having 3 over 1, 6 over 1, 9 over 1, and 12 over 1, which are basically equal to 3, 6, 9, and 12. Since 3, 6, 9, and 12 forms an arithmetic sequence, because we just add the same number, which is 3, to get the next term, then the sequence 1/3, 1/6, 1/9, and 1/12 is harmonic. The last type of sequence is called the Fibonacci sequence. It is named after Leonardo Fibonacci, or also known as Leonardo of Pisa. A Fibonacci sequence is a sequence where its first two terms are either both 1 or 0 and 1, and each term after the first is obtained by adding the two preceding terms. For example, if it is both 1, our sequence will be like this: 1, 1, then 1 plus 1 which is 2, then 1 plus 2 which is 3, then 2 plus 3 is 5, and so on and so forth. The same thing goes for 0 and 1. If they are the first two terms of the Fibonacci sequence, 0 plus 1, 1, then 1 plus 1 is 2, 1 plus 2 is 3, and so on and so forth. Basically, the two are just the same, except the other one has 0 on its start. And these are the other types of number sequence. Again, all in all, we have 4, which are the arithmetic sequence, geometric sequence, harmonic sequence, and the Fibonacci sequence. And that's all you need to know about geometric means, geometric series, and the other types of sequence. I hope you are now ready to answer activities related to it. Again, this is Teacher Anna, and see you on another Matinic episode. Thank you and keep safe.